In the middle of the last century, few people were interested in climate change. Levels of greenhouse gases in the atmosphere were unknown. Temperatures were being recorded, but no one was assembling them to make an accurate global picture. At this time, a young researcher called Charles Keeling was working out a way to measure the level of carbon dioxide in the atmosphere. He found concrete proof that as the level went up and down with the seasons, it was also steadily rising. A few scientists had already said this was likely. Burning fossil fuels rapidly releases millions of years of stored carbon back into the atmosphere. And it was concerning. As a greenhouse gas, carbon dioxide acts like a blanket that traps the heat, so it causes the whole planet to warm up. Fast forward to the present day. We now have a complete picture of how much carbon dioxide has risen in the atmosphere. The level is still rising, and in 2021, it had increased by an astonishing 50% since humans embarked on the Industrial Revolution. But it's the rate of change which is most concerning. Over the last 120 years, other major factors that could influence global temperature have had negligible impact. Factors such as the amount of energy from the sun or the amount of dust from volcanic eruptions that would block the sun's energy from getting through. So, we know that rising levels of greenhouse gases have been the main influence on the climate over the last 120 years. But how much have they affected the temperature of the planet? Years of records from all over the world have now been brought together to give us a picture of how the overall global temperature has changed over time. As expected, it's risen. The temperature is now far higher than it was a century ago. But it's the rapid rate of warming that has been most concerning. The true effect has been masked, though, because 90% of the extra heat has been absorbed by the oceans. Since 1955, we've been able to monitor this too. Over many years, the heat will gradually be released again back into the atmosphere. Even if levels of greenhouse gases can be reduced, unfortunately, this heat will keep global temperatures higher than they otherwise would have been. So far, we've looked at the overall effects, but let's now see how temperatures have changed in various locations across the planet. Let's start in 1901 and run through the years to the present day. The pins show the difference in temperature relative to the middle of the 20th century. Blue pins are cooler. Red pins are warmer. The longer the pins, the greater the difference. Watch how the cooler blue areas gradually disappear, and then the warmer red pins take over as the planet warms up. You can see how the warming has accelerated, particularly in recent years, and some areas have warmed more than others, especially the Arctic. This Arctic warming has had major consequences. Since 1979, satellites have been able to monitor sea ice, and the amount in the Arctic has reduced dramatically. Ice is good at reflecting heat back into space, so the reduction has caused the ice-free ocean to absorb even more heat than it previously would have, causing yet more warming. If we look at the temperature records for Svalbard within the Arctic Circle, the rise has been particularly noticeable in recent years. This has led to the glaciers there dramatically reducing in volume. This shows how the glaciers were in 1936, and this is what they're like now. The red areas highlight how much ice has melted away. But it's not just at this location. In only the last 40 years, the average thickness of the world's glaciers has reduced by 24 meters, the height of an 8-story building. Ice sheets are reducing too. We've only been accurately monitoring these since the 1990s, but in that time, Greenland alone has lost nearly 5,000 gigatons of ice. When melted, that's almost double the volume of Lake Victoria in Africa. All the meltwater from land-based ice sheets and glaciers flows into the oceans, causing the sea level to rise. This is made worse by the ocean waters expanding in size as they warm. This graph shows the global rise in sea level over the last 120 years. Half the increase has happened since the early 90s. As with temperatures, some areas are affected much more than others. Some low-lying areas are already under threat. It is difficult to prove that specific weather events are caused by climate change. But we do know we have seen more extremes as the planet warms. There's been an increase in heat waves, with many temperature records being broken. Changes in rainfall patterns have led to more frequent and severe weather events at either end of the scale, from droughts to floods. The past 9 years were the warmest on record globally. When Keeling first made his discovery, we had little evidence of climate change, but as each year goes by, we gather more data showing how much the climate is changing.